I guess hello everyone. Welcome to my presentation about Puppet and how we use AthenaHealth. You know by now, my name is Andrey Khomyakov. I'm a network architect at AthenaHealth. Before we begin, I'd like to make a couple of remarks. And first, I must mention that there is a book, Learning Puppet 4, by Joe Rett. It's good, it's long, it's fairly detailed. If you're looking to using Puppet, read it. However, it barely touches on managing network equipment with Puppet. The book does walk you from zero to hero, and I have no intention trying to replicate this book in this presentation. There's also Puppet best practices. This is not a commercial plug for either of those books. It's just here as a reference, something that I've used in, as learning material. Second, the most current version of Puppet is version 6, which came out just about a month ago. Our network team at AthenaHealth, we still use Puppet 4, and I don't claim that what I will present today completely applies to Puppet 5 and 6, as I have not looked at what it takes to upgrade. Some of you might wonder, what is the purpose of this presentation? The talk is not really meant to be a definitive guide to Puppet. This is not even meant to be the ultimate authority on Puppet. This presentation is not even meant to teach you basic Puppet skills, as Ethan mentioned earlier. Instead, the purpose of this talk is to make you aware of lessons we have learned on our journey to the automation nirvana. All of the Puppet learning material that I have encountered seems to get you started with learning the Puppet language first, then applying it to one agent, and then growing up from there, eventually building up to using a Puppet master and to control a large number of agents. The issue I find with this approach is that by the time you set up your first Puppet server, you have no idea how this is supposed to look in the real world. All of this is to say that my goal is for you to walk away from this presentation with the general understanding of how a Puppet server can be used to manage a large number of agents and knowledge of some problems that we have discovered. There is surprisingly very little information on best or even just barely good practices for managing networks at scale, leave alone with automation, and even less so with Puppet. So while we do a fair bit of Googling, when we build our system, the information that we find most often is applied to managing servers, and we have to extrapolate that and adapt it to our networking world. So keep that in mind. This talk is more something to keep in mind rather than a set of concrete solutions that you could utilize. Puppet.com, which is the home of Puppet, actually does a terrible job at simply saying what Puppet is. Instead, they use fancy marketing speak to tell you what it does. To me, a Puppet management system actually is a configuration management system. Actually, scratch that. It's a configuration enforcement system even for me. Puppet runs on Linux and Windows. Also, some network vendors have rolled out agents specific to their proprietary operating systems. For example, Arista and Cisco NXOS now allow installation of Puppet agent. Puppet is an open source, free as a puppy, but there is a commercial version called Puppet Enterprise with some fancy features like access management, fancy user interface, and so on. At AthenaHealth, we use open source version, and we are fairly satisfied with it. Obviously, there is no support for your open source version from the vendor, but by now, Puppet is a well-matured system with a lot of resources online to answer almost any question. You might not like the answer sometimes, but you will have the answer to your question. Puppet is good for config management, though in my opinion, it's not so good for managing the running state of the box. This statement is a bit more nuanced than that, but that's the general idea. We also found it to be not very good for upgrades of network hardware. though Puppet can manage package versions. Frequently, Puppet is pitted against Ansible and Chef and lately SaltStack. I can't really tell you which tool is ultimately the best. It is something you will have to evaluate for yourself. For us, it came down to two benefits: having an agent on the managed node that can enforce configuration, even if the control server is down. And our server administrators also use Puppet. So we were banking on the in-house expertise and chance for one day to integrate the two Puppet systems together and kind of have that proverbial single pane of glass. One key difference between Puppet and others is that it is based on Ruby programming language, while, for example, Ansible is Python-based. Some people like Ruby, others absolutely hate it. You will have to decide which one of those you are. I think what makes it or breaks it is in order to use Puppet, you must be able to install an agent on the managed node. Meaning, if you're running Cisco iOS on a Catalyst switch, you just can't install an agent. You don't have the access to that operating system in such a way.
Yeah.
But as I mentioned, vendors such as Arista and Cisco with their NXOS recently allowed access to the base OS, so you start to gain that ability to put an agent on the box. Though, as they say, your mileage may vary. Now that I said that, there are instances where intermediary host is used, meaning that an agent is actually installed on a proxy machine, and then the agent is converting Puppet manifests into device-specific commands that then are executed over SSH or whatever the interface is to that remote box is. But maybe at this point, you might as well just use Ansible as an agentless solution. Without revealing too much detail, here's a bird's eye view of our Puppet managed network. It is not super important how our network looks for this presentation, but probably will help to picture it. We have discrete types of nodes here: leaves, spines, super spines. In the Puppet speak, we call them roles. We actually also manage our management, or we call it out-of-band switches with Puppet, which are not shown here. So they also have roles: out-of-band top of rack switch, out-of-band distribution switch, out-of-band core switch. Now, technically speaking, the only tools our workstations need is Git and a browser to eventually make the pull request. Git is a version control system, just like CVS, Subversion, or Perforce. And talking about Git in any capacity is not really in the scope of this presentation, but the way Git is different from all other version control systems is that it seems to be the most popular now. I'm not here to dwell on the technical aspects of Git, but do know that most of the tools now integrate with Git by default, and then maybe with some other version control system. So just do yourselves a favor and use Git for version control. Another tool most of us make use of to make our life prettier is Microsoft Visual Studio Code that actually Ned showed off in the beginning. All I want to say about it is that it is free and it's actually quite good. So you should totally give it a try, but at the end of the day, all you need is a text editor. Tools like MS Code just make your development life a lot easier. So there you have it, just Git and optionally Microsoft VS Code to edit text files are the only tools of the trade. I put this slide here to give you a rough idea of two concepts in Puppet. And in fact, I think these concepts generally apply to code at large, or at least to the automation. We have data here on the left and code on the right. The code on the right, being in this instance Puppet code, will take the data on the left and generate device-specific configuration out of it. In my case here on the left, I have a snippet of data for a particular switch on my network. On the right, I have a snippet of Puppet code that will take some of this data and generate routing configuration for Quagga or FRR, depending on what is installed. Here's a very high-level overview of our Puppet setup. our change deployment process, for example, changing a VLAN on a port, usually goes something like this. You use Git to change into the production branch on your workstation and pull down the latest version from the Git server. This will be used as your starting point. The production branch is our source of truth. Not what is running on the switch, but what is stored in the production branch of the version control system. The configuration will be generated from the production branch and pushed to the switches. Not the other way around, where we traditionally would back up a switch configuration into maybe a version control system. Then you create a new feature branch. When you create a branch, you can change whatever you like. You're not impacting production in any way. You're not even editing production code. You're editing a copy of it. Next, you make any changes you want, and you push the branch back to the Git server. Even at this point, when you push your change to the Git server, you're still not sending anything to production. All you did here is told the server to store a copy of your modified code. Now you navigate to the Git server and create a pull request into the production branch. Now, what is a pull request, you might ask? A pull request is a request to pull your branch into another branch. So in this case, you are requesting your feature branch to be pulled into the production branch. Then you ask a friend or trusted colleague to review the pull request. This is a step which traditionally, as network engineers, we didn't used to do. Starting to use automation and processes like this one here enables us to peer review each other's work. We sometimes call it code check. Historically, us network engineers, we tend to plan our changes in notepads, and then on that sacrificial change weekend, we cross our fingers and we paste them into the SSH session. Now, this is different. This enforces another set of eyes to make sure that what you are doing is not completely bonkers. In fact, after setting this up, we have caught a lot of, shall we say, interesting things. After your colleague reviews and approves the pull request, you can merge it into the production branch. And then the new version of code gets delivered to the Puppet server. And then as agents check in, they download the changes.
So, Andrey, let me interrupt you for a second. So there's a couple of things here. One is, it feels like if everyone's using the Puppet server infrastructure, you've got a collaborative environment where a bunch of people could be making changes and then requesting that they get merged in.
Right, exactly. So change would have to be merged into the production branch before it actually takes place.
So it's not simply, I'm using Puppet to push a change for me as an individual network engineer. You're part of a collective, a hive mind, that's all the changes that need to go into the network infrastructure need to go through the Puppet server. Everyone's using that. That is the assumption.
Right, exactly. In fact, the result of this process is that the configuration, again, in air quotes, it's not really configuration, right? It's data and the code that turns into configuration. Is stored in the version control repository. So every change is inherently documented. And then unauthorized changes, if someone goes into the switch and does some kind of change out of band, if we say, right, out of the process, because we have an agent on the box, that change will get overwritten every 30 minutes by default. So we are restoring that box to a known state that is in the version control repository.
So if someone goes rogue and starts at the CLI changing configuration, it's going to get brought back to what Puppet believes that it should be.
That's exactly the point, yes.
Yes, yeah. Okay, so in that sense then, actually there's a distinction point I'd like to understand. Which is my single source of truth, the Puppet server or the Git server?
Git server, I suppose, because Puppet server, the only thing it does, it takes code in Git and then makes a copy locally on the server itself. Right, it's a tool.
Server is going to enforce that.
Say it again.
And Puppet server is going to enforce that.
Right. So I'm writing automation code, and then Puppet server turns that automation code into something that Puppet agents can understand and then apply locally on the managed node.
So Git is where all of my code lives, or configuration, however you want to describe it. My single source of truth. The Puppet server's pulling that, knows what that is, and is validating based on communication with the Puppet agents that the actual state of the network is what it is supposed to be. and then enforces any, and make sure that the state is what it's supposed to be by manually overriding any changes that might have been made individually out there on a scheduled time.
Right, right. And then the nuance here is that Puppet will not manage all the configuration on the box. You have to tell it what to manage, right? So the more configuration you manage on the box, the more complete that system becomes.
Oh, interesting. Okay, so this isn't necessarily an all or nothing. You're telling me some parts of my network configuration, maybe I just want to use Puppet to manage my NTP or something like that, and that's all it would have to do. I don't have to have it take over the routing domains and all the rest?
Absolutely. In fact, we started with something simple where we just standardized the message of the day across all of our managed fleet, right? That was the first kind of like what I felt was like, oh, I just used automation for the first time, and I kind of started to understand how that works. This is where I come from the world of conft, right? And then all of a sudden, I have to go into the world of git commits and git push and something else going across and deploying that configuration.
Another thought here about the agent. You mentioned that you have to have a network device that you can run an agent on. So in your case, it's Cumulus devices, right? Or Cumulus Linux is your NOS?
Right. So not quite in this presentation, but I do talk about why we picked Cumulus, and one of them was that it's just Linux, right? And as it's just Linux, I can just put stock Puppet agent on it. I don't have to deal with Arista, Cisco, or anything, whether they allow me or not. So yes, the requirement here is that you must be able to install an agent.
Okay. Okay. So, all right. So I think as we go forward here, you're going to get into some of the background architecture of this and how to, set up your Puppet server to scale to a bunch of devices and all the rest. Is that part of what we're going to get into?
Right. So I was going to talk about the Git server. We'll just skip that.
Sorry, Drew, I cut you off. I didn't. It sounds like you had a question.
But it's all right. We'll just. Oh, you said Drew had a question?
Yeah, just quick, and we don't have to go down the process rabbit hole. But talking about that sort of change control process you've got, is that sort of casual, like just a second set of eyes, or do you have a more formal change control sort of meeting where you go over it and back and forth, or is it just more like there's an email in my inbox, take a look at this config change, yes, no?
It is more casual, but in our case, Git server, and we use Bitbucket right now, will enforce that process, right? Where the creator of the pull request, right? So if I created a feature branch, made my changes, created a pull request, I can't actually merge that code into the production branch until someone else on my team approves it, which means they bear the responsibility for double checking my work. So it is a formal process, but it's not a scheduled process.
So two people will be attached to that change, yeah.
Exactly.
Got
At least
it. Okay.
two people.
Thank
We
you.
actually sometimes make more than one person review it if the change is, impactful enough.
Got it. Thank you.
So let's see what we have time here for. Couple of ways to run Puppet. So I'm going to try to speed through this. Couple of ways to run Puppet. There's Puppet Apply, which is known as serverless, where you have to distribute your actual code base to every agent. And then you have Puppet Server, where the Puppet Server is the only place where you have to keep your code base, and then Puppet Server is responsible for generating the manifests that agents can then download. And we saw an example of that manifest earlier, a couple of slides earlier, where I called it Puppet code, right? There was an example of Puppet manifest. Advantage of Puppet Apply is that you don't have to think about servers, certificate authorities, but you basically have to put the code on the agents, which means sharing secrets with them and agents storing things that they don't particularly need. Puppet Server provides benefits like agent validation, authorization. You don't have to spend processing power on the Puppet nodes, where it becomes very important in the network world where switches traditionally come with bad, slow CPUs, right? So that you don't want to spend CPU cycles on generating configuration on the box. PuppetDB, yep, there is a slide for that. PuppetDB, in Puppet Lab's own words, is the next generation open source storage service for Puppet produced data. Now, the key here is the Puppet produced data, right? So this is not source of truth. You're not storing your configuration in there. This is basically a glorified way to store logs. With that said, you should definitely look into using that day one. It helps a lot. We are today managing close to 500 switches with Puppet, and all from one single VM with 4 vCPUs and 8 gigs of RAM.
And how much of those switch configs are you managing? Just selected bits or the whole thing now?
We are managing, I would say, the whole thing now. So we're managing, switching, routing configuration, authentication configuration, SNMP configuration, message of the day. We using it to download the latest code if we need to. So we basically do everything with Puppet. Right now, for example, we have a project of testing out span links, right? Basically taking every switch and configuring a port as a span port and piping it into a big switch monitoring fabric. So we'll try that by hand, right? And then we'll go and we automate it with Puppet. So now we can deploy that consistent configuration to every switch. So as we need something managed, we just add it to the automation.
Got it.
Right, so in our VM with 4 vCPUs and 8 gigs of RAM, we are using about 25% of resources. So on average, the CPU is 25% utilized and the RAM is about 25% utilized. So we have quite a bit of room to grow. We even have a second server in a different location that is just sitting there as a standby. What we have learned, however, is that Puppet doesn't actually work like that. So you can't just fail over from one server to the other. And by default, your Puppet server was also your Puppet certificate authority, and also you will probably run your Puppet DB on it. The problem is that if you fail over to the other server, all that information is lost. So all those signed certificates, Puppet DB, you basically kind of repointing your agent to the new Puppet server, and they will think that they don't know what that is and fail to communicate with that. So definitely spend the time on understanding how to federate Puppet before you go to production. Yeah, go ahead.
So your agent, in other words, those two servers that you've built up, you've got these two different servers there. Without federation, they don't know enough about each other so that the agent would connect to that secondary Puppet server because of failover or whatever.
Right.
Not have a certificate, not know what this is, can't authenticate to it, doesn't trust it, and certainly isn't going to take any directives from it.
Right. It will actually think that it's a man-in-the-middle attack or something like that, or the connection is being hijacked.
Got it. Okay. So and federation solves the problem.
Well, so to be quite honest, we haven't actually fixed that yet, right? Like in the 3 years that we have been running with Puppet and managing network switches with Puppet, we have not had the need to fail over. So if we do have the need to fail over, today I think we'll just run an Ansible ad hoc job and just blow out all the certificates and have them regenerate as if they're checking in for the first time. All right. The things that we would lose historical Puppet DB data, but at the same time, that failover event will not prevent packets from being passed by the switches, right? This is, again, this configuration management, right? You're not relying on a Puppet server to control the flow of data. So that failover event is fairly out of band. In fact, our Puppet server is on our management network. So it's definitely not impacting the data plane. Does that answer it?
Mm-hmm. Yep.
All right. And yeah, so something I wanted to note about that, right? I do say go look at federation, but if you don't want to spend the time, starting small definitely pays the dividends, kind of especially for people like myself, where I do like my instant gratification. So that message of the day that I was referencing earlier, the fact that I was able to do it without spending, weeks or months on understanding how build Puppet for, a network of 500 nodes, that was something that kind of, oh, this actually works. I can grow this. I can build this. I feel that I have accomplished something. You check that box on your to-do list, right? So start small. And then another note I want to say is that something else not to be afraid of is just start writing code, right? What we are not afraid of at Athena is we are real good at writing bad code, at least on the network team. I hope our core product, the actual AthenaNet, is good code. But what we write for automation is really bad code, right? But it's ugly, it's inefficient. But what it is, it's actually functional. It does what we need it to do. So over the years, we actually rewrote parts of it, stopped using other parts, dropped some of it, but we're definitely not afraid to write just bad code, something that actually helps us progress with automation. And then automating network provisioning is writing code, and as network engineers, we're not really trained to think about it that way, right? So in the software development, we have all these different software release strategies. And at this point, I'm just speeding through because I think I have about 10 minutes left.
Yeah, you got more like 15 minutes. You got till 45 on the hour, 1:45 here on the East Coast of US.
Okay, so we're not really trained to think about software release practices, right? In the software engineering world, there are these strategies that I was able to find that exist about releasing software. And especially here of interest is Canary, right? Where you roll out your code to 5 or 10% of your users. And then if that's successful, you roll it out to the rest of your user base. And really 10% of 2 routers is unfortunately not 1 router, right? So like we have a different kind of problem to solve in the networking world and the automation. So how we apply these strategies in to releasing network automation code and the network equipment, truth to be told, we are still designing that process. So ask me in 6 months what has worked for us. But something that we have definitely learned is what we're going to use is Puppet environments. And if you start learning Puppet, you will quickly realize you will immediately come across Puppet. You will not immediately come across about Puppet dynamic environments. By default, a Puppet agent will use a production, an environment called production. And that's all that is mentioned in the beginner's guide. The trouble here is that as you start going to production, you will eventually discover the dark side of automation, shown here in this lovely diagram. If you're operating a modestly sized network, you have probably learned by now not to roll out your changes to all your infrastructure all at once, but instead start small on one side network and then expand to the rest with time. At AthenaHealth, even before automation and Puppet, we actually had a practice of starting rolling out the change even by hand to our smallest data center that carries the lowest amount of risk and hosts the fewest number of products. And then if that change succeeds there, we would roll out this change to a second data center that has more products, carries more risk, and then if that is happy, then we'll roll out to the biggest data center with the highest risk. Mm-hmm. With Puppet-based automation, we ended up in a situation where the change is everywhere or nowhere. There is no in between. The reason for this is every node by default is in environment production. It was okay at first, as only a small portion of our network equipment was managed with Puppet. And a small portion of the configuration was managed with Puppet, right? To that earlier point, like you don't have to manage the whole thing. But now, as we got more comfortable, we have Puppet managing, as I mentioned, close to 500 nodes. And now imagine a bad change rolling across 500 nodes across all of our data centers. Yeah, I think that's scary. So
okay, so there's a couple of, actually, that is a scary scenario. One is, depending on whether or not you're using an out-of-band network, you could cut yourself off from the network. And of course, the other one being, you just cause a major outage if things went badly. Do you actually run this across an out-of-band network?
We do run our Puppet control network across out-of-band. So that helps as well. We kind of designed it purposefully that way that we can get into the equipment even if the data plane is down. And then we don't really make a whole lot of changes to the out-of-band network to begin with, so it's fairly stable. Most of the changes go to the production network. I don't think we have run into the instance of where we cut ourselves off from the management side of the house. So we definitely had changes where a routing would be broken, but I could still get into the switch and revert it, or even just in the automation world, I would just undo my pull request. Right, like I merged that into production, it started rolling, I noticed that it's broken, I quickly undid it, and then the previous known good code version, if you will, rolled back and then restored all that, right?
I got a couple of questions that have flowed in from the audience since we're at a pause here, then you can pick back up. One is just Puppet compatibility across different vendors like Cisco, Juniper, et cetera. I assume that means, in this context, are there agents available, and what platforms can I get a Puppet agent for on Cisco, Juniper, and so on? Do you happen to know?
So I can only speak from my experience. I know that Cisco NXOS supports Puppet Agent. Arista, what's it called? EOS supports Puppet Agent. I don't know for a fact about Juniper or any other vendors.
I'm pretty sure about Juniper. I mean, I remember seeing a Puppet demo from Juniper years ago, and I don't imagine they would have pulled that support, but I'm not positive, but I believe so.
Yeah, this is where kind of like what it makes it or breaks it for using Puppet. If you can put the agent on the box, you're good to go. And my philosophical approach is that I want the agent enforcing that configuration regardless of the fact whether the control server is available or not to tell the switch to enforce it, right? Some people argue that Ansible, for example, is a different approach where, especially if you're managing boxes like Cisco or traditional network operating systems, you're not beholden to the vendor support of the solution, right? You can basically pretend you're a human with these tools.
Another question regarding Cisco NXOS specifically. If you install an agent on NXOS, are you installing the agent in the guest shell or the bash shell?
I don't remember. I know we tried using Puppet on NXOS. It was in the early days of our Puppet expertise, so we perhaps didn't take the right approach of this, so we gave up on it. We haven't tried to redo it since then. I think that installs in a bash shell, if I'm not mistaken. That was a long time ago.
And then yet another question regarding IP address schemas. How do you fetch an IP address schema for a new device or a new device role? Do you use IPAM? Do you have some other method for handling your IP address schema?
We do right now provision IP addresses by hand, as in like you go into that YAML file. We saw some slides earlier on the left, the data, and you type in the addresses, right? So that step is still not yet automated. You go into IPAM as a human, you find your IP addresses, put them in the data file, right? We are working, albeit slowly, on kind of automating that part as well. With that said, FRR supports unnumbered interfaces very well, running BGP over IPv6 link local. So assigning IP addresses to interfaces is actually not that big of a problem for us. We just use unnumbered interfaces.
Okay. Yet more questions rolling in for you, so we'll keep going. What happens if the agent goes into check or goes to check in and the Puppet server is not available?
The Puppet agent by default will cache the last manifest that was provided to it. So that was kind of that philosophical approach, right? Where Puppet agent will cache the last manifest. Now, if you remove the control server, the Puppet server, and it's dead, it will just keep enforcing that last known state. So if you then go to that agent and you make an out-of-band change, that agent will, next time it runs Puppet on a schedule locally, it will compare it to the cached manifest and then override all the local changes back to the local manifest, right? And that's where the agent can enforce the state on the box without some remote entity like an Ansible control server telling it to do so.
Okay, now before we get into all of these questions, we were talking about it is possible to clobber 500 devices with a bad change, that it rolls out. So the question comes in from the audience, and I think this means you get to pick back up with your presentation, Andrey. The question, what is a strategy for doing an incremental rollout, or is Puppet just not suited for that right now?
So Puppet is suited for that. So I actually have, in fact, we are right on that slide right now. This is where we as network engineers don't tend to think about releasing code, right? And as I was learning this, I did not even know what I was researching, right? So I was going to talk a lot about on code deploy and environments and whatever, but basically Google release engineering. This is the official term that, as a network engineer, I realized I needed to understand, because I was Googling, how do you deploy change with Puppet or this and that? And eventually I realized that what I was researching is code release practices. So code deploy, code release, turns out those are two different things. you also have to think of Puppet uses environments, right? So Puppet has a concept of dynamic environments where you can put some of your nodes in one environment, some of your nodes in the other environment. So I'm actually designing a process right now for us internally where we'll say we have a dynamic, we have a canary environment. Let's say we assign a row of racks to that environment, right? So I roll my change to that environment first. Then if that succeeds, maybe I have a second environment that's my acceptance, and that's maybe another 5 rows of racks or something like that. Then I roll my change, I merge my code into that environment, right? And that's my bigger scope, but still not all of production. So I can use Puppet dynamic environments to limit that scope of rollout. And the tool actually that does that, let's see where we are. There you go. And the tool that actually does that is called R10K. Right, so there are actually several well-documented release strategies in the world of Puppet in particular, because software development strategies don't directly apply to Puppet, but they help to understand what you're doing. Mm-hmm. And in the Git world, right, so here, if you don't know anything about Git, Git basically operates on the concept of branches. You have your master branch, which is probably your production-grade code, your source of truth. And then the best practice is to never work on the master branch. You create a feature branch, and then you do all your changes in your feature branch when you're happy, and you tested it everywhere, let's say in your virtual environment, like your model environment, or we have also a physical lab where we can test how our changes apply to ASICs, for example, that you can't test in a virtual environment. When you're all happy with that, then you create a pull request and you merge it into your master branch or your production branch or whatever you designate it as your source of truth, right? R10K is a tool that will build Puppet dynamic environments based on Git branches. So here I have a list of Puppet environments, right? And if you know Linux, you understand that this, I'm showing you folders. And the Etsy Puppet Labs code environment, I'm showing you folders. In the Git world, a Git project, your single folder with all your code, branches are basically being magically slipped in. If you say git checkout and the name of the branch, you stay within the same folder. Git subsystem just slips in the code in that branch that you're checking out. So how do you convert branches shown here on the left in the red, all my Git branches that are stored on the Git server? How do you convert them into folders? And Puppet uses these folders as environments. So on the right here, I have Puppet environments, and most of them don't have any agents. Most of my agents are in the production environment. But then I can put some of my agents in a testing environment, some of my agents are in a lab environment, right? So if I take my feature branch and I make my changes in the feature branch, I can then take my feature branch and merge it into the testing. And then all the agents that are in the testing environment will get that change, but no production agents will get that.
Okay,
right?
So basically you leverage environments, put the right devices into the right environment, and now you've got a way to still use a central code repository, if you will, but control who's getting which changes and see how things go before you push them into the production environment, let's say.
Right. And you can even get more granular than that, right? Because Puppet creates R10K creates a Puppet environment out of the branch name. You don't even have to merge it into any other branch. Puppet, if you notice here, I have a couple of branches that are called feature something, right? There's some internal bug IDs there that we use. But basically, those two branches that start with feature, that is something that we were working on, let's say, with Kubernetes, right? This is my feature. So now I go and I connect to one agent and I say, I want to test how this code applies to a real switch. So I log into the switch and I say, you are now a member of that feature environment as opposed to production environment, right? And now the change that I am developing only goes to that one switch. So I don't have to merge it anywhere. I'm no longer risking rolling bad change that I have developed to 100 nodes or 500 nodes, right? So it gives you that flexibility. So the lesson basically I'm trying to kind of get across here is that start with Puppet dynamic environments, and definitely start with R10K. We made that mistake 2-3 years ago, and only now we had the time to kind of pay down that technical debt and convert to this approach.
In other words, if you don't start with dynamic environments and you don't start with R10K, it's going to suck when you try to add them. It's not easy to just, turn those on.
Right. It's not super hard to turn them on, but you will have to kind of follow one process. Then it's like, well, this is starting to really hurt me, and then you have to rebuild the process. So you'll have to decide how quickly you want to go to market with your tool, right? I would say that R10K is super easy tool to understand. It actually just does two things. One of them is building Puppet environments based on branch names, and the other thing is, let's see if we have a slide on that. Oh, and the other thing it does this. There's also Puppet file, right, where Puppet, since it's been such a mature system and well used in the server community, there are thousands upon thousands of Puppet modules. And a Puppet module is a bundle of code and data that's designed to complete a particular task. For example, configure an LDAP client, right? Or we have a Puppet module that we wrote that configures the interfaces on the box. So it takes the data and then it runs it through some automation code and spits out Etsy network interfaces file to put on a switch. So a lot of these things are already written and shared by the internet community at large, something like configuring an LDAP client or managing packages or something like that. So we made a mistake of installing these modules by hand. And the problem is that if you install them by hand, they become shared across all your environments. And then when you want to upgrade the module, you impact all your environments all at the same time. And then you still have to install them by hand. The second thing R10K tool does is use what's called a Puppet file. In a Puppet file, you really just do two things. You tell R10K tool where to install the third-party modules and what modules to install and what versions to install of those modules. And then you have this Puppet file that also is in your version control repository, and you can install modules per environment. And that way, when you upgrade your modules, you say you create a feature branch, you tell it to you specify new versions for the modules. Let's say here I have stdlib version 425. What if 426 came out and I want to test it how it works? I create a new feature branch and I say, here we're going to use 426, and R10K will install that module in your feature environment without even touching the production, right? So that kind of reduces the scope of your impact when you upgrade a third-party module. Does that make sense?
It does. I'm not sure how much more you got left. There was one question I think is a real good one to address, though. So let me give you some context. So in the Slack channel, PPVDC2, some people have been chatting about their favorite automation tool. And a lot of people are like, I haven't really heard of anyone using Puppet for network automation. We use Ansible or whatever they use. Ansible seems to be the most popular choice. And then someone else is just asking that question right out. Why are you guys using Puppet? Does it have something or some features or options that other choices didn't have?
Two main reasons we chose Puppet. Agent on the box, meaning to enforce that state even if the control server is dead, right? So in Ansible, there is a concept of where you have a control node, whether that's a server or it's your laptop, but you have to go and run Ansible and say, click the play button, if you will, and say, go connect to all these nodes and make sure that they are in the state I want them to be in, right? But that is an initiated activity. Yes, you can put it in a cron job on the control server, right? But generally speaking, if that control server is misbehaving or doing something wrong, you are no longer enforcing that state. Puppet agent, as I mentioned on the box, it will use the last cached manifest and will enforce it continuously every time the agent is running, right? And then the second, we are a big Puppet shop on the server side. So we have a lot of in-house expertise from the server admins, and we want to eventually integrate into the main production Puppet system and kind of walk away from managing our own Puppet infrastructure and just use, if you will, Puppet as a service that someone else provides to us with more expertise, right? Like as a network engineer, I don't need to be an expert on Puppet and how to scale that system. So those are the two main reasons we chose Puppet. And then at the time when we had to make a decision, we just said, hell, Puppet, those two reasons are good enough.
So Andrey, we're about at the time that we wanted to end your presentation. How much is left?
We'll skip that. So actually not a whole lot of time is left. So this is basically a one slide summary of what I wanted to talk about in the whole presentation. So we are at the end.